start the session. Am I audible? Let me check again. Okay. Okay. So, welcome to the 11th tutorial session of Operation Planning of Power Distribution System. I am Satya, a PMRF Research Scholar at Department of Energy Science Engineering, IT Bombay. So, in this, we will see few of the problems related to microgrid, few of the solar-based basic numerical, and also few wind-based problem we will see. So, without wasting time, let's move further. Try to solve this first problem in front of you. So this is problem related to the microgrid, and there are five statement are there. You just have to let me know which statement is actually correct and which is false. There can be multiple answers can be correct. I think. So let me see. Multiple can be correct and multiple can be false. Okay. Okay. I got one answer at option A and option B is correct. A and B is correct. Okay. I got one more answer at A and C. Okay. I request others also to check. Let me give me one second. Option A, B, and C is correct. Okay. I got one more answer. A, B, and C is correct. Okay. Let me give the solution. Okay. Let me see which options are actually correct. Okay. So as you see the first statement, what it is actually telling. Okay. First statement is telling that the microgrid are the decentralized energy systems that can operate independently or in conjunction with the main power grid. Okay. So how these structures are there? So how the normal conventional generators are there? So this is the generator and thermal with it connected to whether it is a thermal power plant or a hydropower plant. So you have a generating station, and then you have a in between line. Then it is connected to the load. Okay. So what happens in the microgrids? Microgrid are basically decentralized, not centralized system. They are decentralized systems which can be independently can operate. Okay. So here when you see here I have connected here the solar PV panel. Okay. Okay. So this is generating power and giving to the grid, and it is connected here at a PCC. This is called PCC. PCC is the point of interconnection where the at the end of the after the filter if it is an inverter is there after the LC filter, the point which comes that is called as a PCC. So this DER when you see this is a solar plant and it supplies the power to the house, and also it can send extra power to the grid, okay, in the grid mode operation. But when the grid is not there and there is a outage is there, so it can also supply the power to the house, okay, and generate only that much which is required. So it can operate independently also, and also in the conjunction with the main power grid, okay. Second statement means option A is actually correct, okay. Second statement, option B, is saying if microgrid typically relies only on the RE sources such as solar and wind for their power generation. That is true that solar and wind is fine, but you have other generating sources also, like you have biomass, okay. That also is a kind of considered as a decentralized microgrid, and also it can generate and power and supply to the grid, okay. And also you have biomass and also some other generating sources, which is basically the small hydro, okay. So they are considered as a RE based sources, and also they can typically consider as a microgrid, but not specifically that saying that ki only the solar and wind are considered as a microgrid, okay. So this statement is false. You have the other generating sources as well. Biomass is there, and hydro is there, pump storage is there. So they are the different kind of RE based sources are there, which also can be considered in the microgrid, okay. Option C, when you see the primary purpose of microgrid is to provide a reliable and stable power supply during the outages, okay. That is also correct, because when you are connected to the grid and there is a grid outage happens, and we are independent. Suppose we have a house which is having a solar installation, and it is independent, and you have a battery storage also. So battery storage can supply during the non-solar hours, and when the solar hour is there, so you can supply the power to the house through that solar, okay. So this is the main purpose, to supply the reliable power operation to the house or any system during the grid outages condition, okay. Microgrid are mainly used in urban areas and have limited applicability in the rural or remote location. That is false. You can install the solar at the remote location also. You can see the right side image. There is a island is there where we have kept the generating sources from the wind and solar. Okay, so there the island where the putting the transmission line through the ocean, it is difficult. So there we use the battery storage. Plants with the solar, with the wind, okay, to supply the power, okay. You can see here the battery storage is there, okay. So that is the means ki false statement, which is trying to say that it can have installation only in the urban area. That is false, okay. When you see the other question, that is advanced control system are essential for optimizing the performance of the microgrid and balancing the supply and demand. That is true, because you have to generate that much power which is there at the demand side, okay. You should not generate if it is in the when it is independent to the grid, that is called as islanded operation, okay. In this scenario we are independent and we are generating that much which is required at the load side. But when you are grid connected system, you can generate the power demand maximum, okay. You can supply the load also, and you can also give to the grid, okay. So this is the but for developing this kind of algorithm, you need an advanced control system to operate, okay. So the third statement means correct option is the A, C, and E is correct. Okay, A, C, and E is correct. Okay, any doubt? Okay, geothermal and tidal. That is tidal is basically that means hydro only. Sorry, tidal is basically decentralized also through the ocean waves. That is, and hydel is basically the hydro. So these are the power plant which you can operate. That is true. Okay. So let's move further, try to solve this problem. This is a smaller problem, but I needed you to just give a glimpse of that. Okay, that's easy to solve. Okay, anyone else? Let's give 10 more seconds. Okay, So option B is correct, that we already know. This is a smaller problem. Just you have to do the power. Power is equal to voltage VDC into IDC. Okay, it will generate DC. The power is given 180, so voltage is 20 multiplied by IDC. What will be the IDC? IDC is basically 30 divided by 6 amps. Okay. The main objective to give this question is that to give a topology. Okay. When you have a solar generation basically, suppose I have connected a PV plant here. Okay, PV PV here, and then this is generating DC. Okay, so this is a basically fluctuating DC, and you required a constant DC. So you connect a capacitor in between to regulate the voltage and keep it as a constant. That is called VDC. And then you have boost converter. Okay, so boost converter to boost the voltage to which is required. Okay, suppose I require the here certain amount, so V requirement, whatever you require, you just boosted the voltage from the level you are getting currently from the PV side. Okay, then this is also DC, and this is also DC you are getting. Okay, now for the connection with the grid, you need a DC to AC converter. Okay, DC to AC converter that will be connected to the grid. Okay, okay, which is required. Okay, so for single phase AC system, you need the certain DC voltage. Suppose this is also VDC. This is the DC link voltage. Okay, and DC link voltage have to be maintained at a certain voltage level to give the supply from the AC to DC. Okay, this is single phase supply 230 volt. So in that sense also you have to boost the VDC so that you can get the 2 volt 230 volt reference at the grid side. Okay, so that is very very important, that topology I wanted to explain, so that's why I have given this problem. Okay, let's move further, try to solve this problem. That's correct. Okay, so option B is correct. You just have to divide the voltage and you can get the means how many number of panels are actually required. Okay, in this question, the important point is that I wanted to explain the series and parallel connection. Okay, so how the panels get connected, how the PV panels actually get connected. Okay, suppose for the generation, suppose this is the one DC PV panel is there, so it will have two points, one is the positive, one is the negative. Okay, suppose I wanted to make a string out of that. Okay, so then through this negative you will connect another PV panel. Okay, PV module, basically this is the module we call. Okay, module. And when the lot of modules get connected in the series and parallel configuration as per the current and voltage rating, so you will get the a overall array. Okay, so here when you see here it is connected with the positive of this, and then it is negative get out, and here it is connected to another module. Okay, and then it is similarly. Okay, so whatever the, suppose this is the voltage of 30 volt. Okay, then we have connected again a 30 volt, then again we have connected a 30 volt. Okay, so here when you see what you are getting at a negative here and the positive here, what you are getting 90 volt. Okay, so this is a kind of a array. So this is a arrangement of a series combination where we have increased the voltage. Okay, but the current when you see it is actually constant. Okay, because they are connected in the series fashion. Okay, so suppose this is a at a max it can generate 300 watt. This is also generating 300 watt. This is also 300 watt. Okay, so when you see the voltages, the current which will flow from here, it will be constant. You cannot connect the multiple voltage level panels in between. Okay, though. Okay, in the parallel fashion basically, but in the series you can connect. So here what you are getting the 90 volt, but the current will be constantly there. Okay. Suppose I wanted to increase the current rating of that, then you have to connect the PV modules in the parallel fashion. Okay. Suppose like this. So there are panels will be like this, one module, and then you connecting again a module here. Okay. So then you can connect, make a string out of that. Okay. Like this. So here you connected, you created a string. Okay. And then it will be connected to somewhere the inverter, or you have a central inverter also. This is the distributed inverters are there for each string. This is called one string. Okay. So so this, if through this you can increase the current rating also. So you have current rating, basically from current will come here. So I here you, what you will get, that is 2i. Okay. Here what you are getting, it is I only. Okay. So based upon the whatever the current requirement is there, how much voltage requirement is there, you can connect the panels in the series and panel and make a string out of that. Okay. Let's move further, try to solve this problem. Hello, Ayush. Hello. Emma, let me give the solution for this. So when you see the PV panels, when it is connected, it is a 250 watt. The power rating is given, and the voltage rating is given as a 25 volt. Okay, so you can means calculate the current which is come from the this unit. Okay, so this is 250 divided by 225 volt. That is the 10 amps. Okay, so this is the current. Okay, so when you see the array which is required to supply the 20 amps at a 200 volt, okay. So but here when you see one PV panel, it's a 25 volt. So you can find out what is the number of panels connected, okay, to supply 200 volt, to give 200 volt, okay. You can calculate 200 divided by 25, it will come out to be 8, okay. 24 4 multiplied to 8, okay. Now you have got the voltage range, but you have to make the string out of that to increase the current rating also, because you are getting the 10 amps, okay. So same number you have to attach in the parallel fashion to get the same number, means ki 10 20 amps, okay. So number of panels to be connected, okay, connected for at 20 amps, it will be simply 8 multiplied by 10 divided by 2. Sorry, 20 divided by 10. That will come out to be 16. That is option C. Okay. So what is the architecture basically? Architecture is like this. Okay. So this will be one, this, then it is connected to like this, and dot dot dot. So this will be the eighth module. So this is first, this is second, this is eighth. And this is giving the 10 amps. Okay. But you needed the another 10 amps also to make it 20 amps. Okay. Then you have to give the 10 amps from here as well. So same string we have connected here. Okay. Okay. Okay, like this. So you have 8 units here and 1 to 8 units here. So 8 multiplied by 2 is the 16 units. Okay, so this is option C. Okay, getting my point. So the correct answer is the option C. Okay, let's move further. Try to solve this. This is related to the wind, but formula you have to remember in these problems. Okay, try to solve, otherwise I will give the solution for this. Okay, option A, I got one answer. Okay, option C also I got. Okay, let me give the formula. Okay, so that will be easy for you to solve. So the formula basically is the half rho A V cube. Okay, so this is the power formula, but there is also a factor that is called CP. Okay, so the overall formula from here is the half rho A Cp V cube. Okay, power is proportional to the V cube. Okay, but here the Cp term is not given. You can consider Cp as in 1. Okay, so then calculating what you will get, half multiplied by rho. Rho is given as 1.225 kilogram per meter cube. Okay, half rho, Cp is 1. Okay, now it you have to multiply the 5. Okay, 5 cube. Okay, then multiply by the area. Area is basically pi r square. Pi r square, that is a 20 of square. Okay. So after calculating, you will get the value. Okay. So that is the important point you have to understand here, that what you are getting here, unit when you see. So this is the kilogram per meter cube. Okay, multiplying by the meter cube, multiplying by pi r square, it's a meter of square, so you get the kilogram meter square. So there is the factor of the cp comes into picture to make it as a in the kilowatt terms. Okay, so that's why when you calculate, it will come out to be nearly 96.2. Option C is actually correct. Okay. So from area swept, you already know pi r square, and then you calculate half rho a v cube, and from that you will calculate 96.2. But the CV factor is also important here. Okay. Remember this formula. Let's move further, try to solve this. Okay, option C I got. Let's wait for others also to solve. Okay, I got another option C. Okay, let's wait for one more minute. After that, I will give the solution. Let's other also to solve. Okay, I got one answer as option D. Okay. Okay, listen here. So let me give the solution. So we already know what is the power equation. Okay, power equation is basically half rho A Cp and V cube. Okay, Cp is not given, so you consider it as a 1. So power is already given. Power is given 50 kilowatt. 50 into 10 to the power 3 is equal to half. Rho is given, that is 1.225. Okay, multiplied by A. A is means that radius is actually required, so that is a pi r square. Okay, multiplied by v cube. V cube is given at 6. Okay, so from here you can get the r value. R value through after solving it will come out to be option C, that is 10.97, usually nearly 11 meter. Okay, so the 11 meter is the correct answer. Okay, so just you have to use the formula and you have to uh, 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 just put the value whatever the given, and then you can find out which is required. Okay, let's move further, try to solve this problem. If you don't know the formula or you don't able not able to understand the problem, just write in the chat box that explain. Okay, so I will directly jump to the explanation part of this problem. Okay, I got one answer at option C. Okay, let's wait for then for others also to solve. Okay, let me give the solution for this. So listen here. So what in the problem is saying, when you have a 10-meter height of windmill is there. Okay, so this is the 10 meter. So the wind speed which is it is being seen here. So that is the 6 meter per second. Okay, and then this guide height got increased to 40 meter. Okay, now it will experience the more wind speed. Okay, so it was asked that key, if you are having a roughness exponent of 0.14, so what will be the speed which is required here? So there is a one formula. Okay, so basically the v2, the wind velocity, which is equal to the v1 h2 minus h1 power alpha. Okay, or you can say that ki v1 by h1. Okay, v2 sorry, v2 by v1 is actually equal to h2 by h1 power alpha, or you can say the voltage is proportional to h to the power alpha. Okay, so alpha is basically the roughness factor. Okay, so when you put the values of and wanted to find it out, the v2 is equal to v1 h2 by h1 power alpha. Okay, so what is the v2? V1, v1 is already given, that is 6. H2 is given as 40 divided by 10 power 1.14. Okay, when you solve it will come out to be option C, 7.3 meter per second. Okay, you just remember the formula. Okay, that voltage is proportional to the height with the exponent in the cause as a roughness exponent basically. Okay, try to solve this. Okay, I got one answer, option C. Let's wait for others also to solve. Okay, I got one more answer, option C. Let me give some more time to other for others also to understand. Okay, option C. Okay, let me give the solution. So you have to remember a one concept here. Uh, this. Okay. So there is a formula called this relating to the wind turbine blade and the tip by means tip speed ratio. So you have this formula called lambda is equal to omega r by v. Okay. So it is given that wind build turbine radius is 15 meter. Okay. Tip speed ratio is the 5 and wind velocity is given 8. Okay. Radius already know, we r is equal to 15 meter. Okay, and the omega is basically what is given here, that is being asked. What is here in what is the rotor speed? Okay, so rotor speed you can find it out, what is there. Okay, so lambda is basically 5, that is called as a tip speed ratio. That is given as a 5. Okay, and the v velocity is given 8. Okay, just put the value. 5 is equal to omega, r is given 15, and the 8. Okay, 5 3 you can cut. Omega is equal to something, uh, I think I have missed something. 5 8 divided by 15, it will come out to be 2.667 radian per second. Okay, so, but it is in your question when you say it is given in the RPM, it is being asked in the RPM. Okay, so omega, when you see this, n is basically omega multiplied by 60 by 2 pi. Okay, so omega is 2.667 multiplied by 60 divided by 2 pi. Okay, when you find it out, it will come out to be nearly 25.5 RPM. So it is matching with the option C. Okay. So this is the correct answer. Just remember the this formula, lambda is equal to omega r by v, and this formula when you are converting from the radian per second to the RPM. Okay, okay. Let's move further. Try to solve this. This is concept related to the battery storage. Okay, I got one answer at option B. Okay, let's wait for others also to solve. Okay, I got one answer correct. Multiple answer is option B. Okay. So in this problem, that is correct. That option B is correct here. You just have to, because when you see the battery, okay, it has certain SOC. Okay, SOC means ki it is proportional to the energy. Okay, so if suppose you have 100% SOC, it means that you can use whatever the rated capacity. Suppose I have a battery storage of 40 kilowatt hour. Okay, so you can use the 40 kilowatt hour if you charge to the 100%. Suppose I have charged to 20%, so accordingly with the you can convert 40 divided by 100 multiplied by 20. This is the utilizable capacity you can have. Okay, 20 minus, so 8 kilowatt hour. Okay, so similarly the battery stored energy is basically kilowatt hour. Okay, so this is given voltage and this is in the ampere hour. Just multiply both, you will get 48 multiplied by 120 kilowatt watt hour. Okay, watt hour. Okay, just when you solve it, how much it is coming? It is coming 5.76 kilowatt hour. Okay, so it is saying that ki allowable it used to 80% of the stored SOC. So zero point 0.8 multiplied by 5.76, when you do, it will come out to be option B, that is 4.61 nearly. Okay. So this is a kind of always remember SOC is proportional to energy. So whatever the SOC is, suppose in this question if it is means such that like this. Okay, so you can use, as you have a SOC minimum of 20%. Okay, and SOC max means ki 80%. Okay, so it means that you cannot go below the certain SOC and you cannot charge the vehicle above the certain SOC. Okay, then what is the allowable use means ki allowable usable capacity? Okay, in this scenario you have to suppose I consider 40 kilowatt hour battery is there. So in this scenario, zero point 0.8 multiplied by 40, that is equal to 32 kilowatt hour is the max, and then zero point 0.2 multiplied by 40, that will come out to be 8 kilowatt hour. Okay, so what is the utilizable energy? Energy basically 32 minus 8, that is come out to be 24. Okay, this is the utilizable energy, because you are not going below certain SOC, you are not going above than certain SOC. Okay, so remember this concept. Try to solve this problem. Okay, I got one as option C. Others? Okay, let's wait for 10-15 more seconds. Okay. Okay, that's correct. Means ki when you have the 12 point means ki 12 kilowatt hour capacity battery, so energy is basically power multiplied by time. Okay, so energy is given 12 kilowatt hour, power is given 3 kilowatt. So time factor you can calculate. Time is basically 12 divided by 3. This is basically the 4 hour. Okay, so the backup time is basically 4 hour. Okay, so the option C is actually correct. Okay, let's move further. Try to solve this. Okay, option B, I got one. Let's wait for a few more minutes. Others also to solve. Take your time, okay? No problem. Okay, I got another answer, option C. Okay. Okay, listen here. Let me give the solution. Okay. Listen, see here. So what in the question is telling that a 40 kilowatt hour battery is initially at a 70% of the SOC. It delivers 10 kilowatt hour of energy to the load. What is the new SOC basically? Okay. So what I have told that ki energy is proportional to SOC, or you can say in the reverse manner that SOC is proportional to energy. Okay. So 100% SOC means 40 kilowatt hour. Okay. 70% means, okay, 70% means 70 multiplied by zero point 0.4. Okay. It will come out to be 28 kilowatt hour. Okay. It is telling that ki 10 kilowatt hour is being supplied to the load. Okay. So now the new energy left is equal to 28 minus 10, that is equal to 18 kilowatt hour. Okay. So and we already know 40 kilowatt hour is 100%. Okay. So the 1 kilowatt hour is 100 by 40. Okay. So how, what is the 18 kilowatt hour? 18 kilowatt hour is basically 100 divided by 40 multiplied by 18. Okay. When you solve for 2.5, it's fourth, it's 25 divided by fourth. Okay. 4 4 16. Okay, it is coming out to be nearly C, 45%. Okay, nearly 45%. Okay. Yeah. So this is basically 18 kilowatt hour which is being left, and then we have calculated the new SOC at 18 divided by 40 multiplied by 100, that is 45%. Okay. You just have to remember that SOC is proportional to energy. Whatever 100% SOC means full capacity of the battery. Okay. Let's move further. Try a few statement-based problem we have here, and just try to solve whether this statement is correct or not. Okay. Try to solve. Okay, let's wait for a few more seconds. Okay, option A. Okay, okay. So that is correct. The option A is actually correct because It actually smart grid concept is like that. When you add the communication and control part to the conventional grid, so that is basically come into the like controlling the real time monitoring and real time communication happens in between the different unit. That is called a smart grid. Okay, so in that we put the some devices like intelligent devices like smart and some of the smart meter, advanced communication. For storing the data, we need the data acquisition system, and also some parameters will be there in the analog, some will be in the digital. You need the DAC for that. Okay, digital to analog conversion devices or analog to digital conversion devices, and real-time control features also. Suppose I wanted to curtail the solar PV plant, so to off that you need the real-time control of that PV plant. Okay, and the smart grid expect a electrical grid, but advanced communication and IT, that is correct, and the first is also correct. Third statement is removes the need of communication interface, that is false. We need the communication infrastructure. Okay. Smart grid operate without real-time control, that is false. Okay. We need the real-time control, real-time communication and dash devices, real-time monitoring also, smart meter features. Okay. So the option A is correct. Let's move further, try to solve this. Okay, option A I got. Let's wait for a few more minutes. Okay, option A. Okay, option A. Okay, option A. Okay. So let me see what is the correct answer. So it is the three statements are correct basically. So it's a one, two, three also. Okay. So first statement is correct because you can have a central distribution system, means ki, generation option also, distributed also, intermittent also, mobile also. Central means you have a, suppose you have a central system and it is connected to different DERs. Okay, so you need a central system to monitor that. Suppose you have a PV plant here, you have a wind, you have a BSS here, you have a suppose biomass plant is there. So you need a real-time monitoring, real-time centralized control of that. And also you can use the distributed also, means this PV plant is operating somewhere with the some other mechanism, so that can be there. Intermittent is there because we don't predict okay, what will be the solar generation at the next moment. Okay, mobile generation also because you have the EVs also. So these are kind of that can support the grid or during the like V2G or V2S services. Okay, so this kind of function is also there in the smart grid feature. So they are, so option A is actually correct. When you talk about the second option, that customer to interact with the EMS to adjust uses. Okay, suppose in a house you have a different component. Okay, like you have a AC, you have refrigerator. Okay, you have heaters also. Okay, so in that scenario you need you can control your devices to smartly, and you can reduce the power consumption of your house. Okay, you just have to create or put a certain unit here in between. Okay, in between you just keep one smart device in between. Okay, that can be and here also they will monitor and give certain command to the EMS, means energy management system, and it sees that keep power consumption. Suppose this is a where the peak load time is there. Okay, you just curtail this AC or refrigerator to reduce the power in that scenario, so that the uh, power cannot means ki energy should not be consumption should not be higher in that time frame where the tariff rates are higher. Okay, and also this third is also correct because cell smart grid is such that ki it should whatever the fault came into the system, it will automatically try to restore it. Okay, suppose the power whatever the demand is required, the source should already must supply the load in that scenario by cutting out the whatever the faulty phases are there. Okay, so that is also it should be expected, and after the fault restored, then it should come back into the normal operation by itself. Okay, fourth is that smart grid must completely replace the existing electrical power grid. That is not possible because you have already kept the cables in, you have already kept the distribution transformer, you are already having the feeders. Okay, for removing completely, you need a lot of monitor means ki, infrastructure upgradation cost. Okay, so that is not feasible option. So it can happen in the future, but must completely replace, that is not a practical solution. Okay, so the option B is correct. Okay, option B is actually correct. Option A 1 to 3. Okay, let's move further, try to solve this. Okay, I got one answer at option A. Let's wait for others also to solve and check whether your answer is correct or not. Re-verify. Okay, let me give the solution for this. So, in this problem, when you see there, you have to read and you have to know the what is the full form of this ID, RTU, and DNP3. Okay. So ID is basically intelligent electronic devices that is defined as a device incorporating one or more processor with the capability to receive or send and control from and to from the external sources. So they are basically the digital relay which can take the input from the different unit and also give this input that key we are in the normally open condition or normally closed condition. So that is basically the intelligent electronic devices. Okay, that is required, that is true. Second option is saying ki RTU. RTU is the remote terminal unit. They are include the entire set of devices, modules, and assemblies that can electrically interconnected to perform remote station supervisory functions. Suppose you have a SCADA system and you have plants some other places located at a far end. So you need a SCADA system at a central that can monitor all the system remotely and give the command from there. Okay, so that is called a remote terminal unit. It is kind of a SCADA system. Okay. What about the DNP3? DNP3 is basically the distributed network protocol. This is a non-proprietary communication protocol. This is designed to optimize the transmission data. Okay, dash system and a control command. Okay, from one computer to the another computer. So you have a suppose distributed networks are there. Different computers have been kept at a different location. You just needed a DNP3 protocol or distributed network protocol to transmit the data from one system to the other system. Okay, so that is basically DNP3. And the last statement, what is stated, demand response refers only to increasing the generation and nothing to, but that is false. Whatever the demand is there, that much needed the supply you have to give. Okay, so the demand response is very important. Okay, and as soon as the demand fluctuate, you have to fluctuate your supply based upon that. Okay, let's move further, try to solve this. Okay, let's wait for a few more seconds. Okay, option A, option A. Okay, that is true. That is true. That smart grid permits two-way flow of electricity and information. That is true. Existing grid mainly uses the one-way communication. That is true. Smart grid supports only centralized generation. That is false. You have a distributed generation also and centralized generation as well. So existing grid is self-healing in nature. That is false. Okay, smart grid having the feature of the self healing process. Okay, so 3 4 is incorrect, so option A is correct. Okay, let's move further, try to solve this. Okay, I got one answer, option B. Okay, okay, option B. Okay, okay, let's wait for 5 10 more seconds. Okay, so that is true. First, second, third options are correct. Option B is correct. So the major need of a smart grid is basically to when you have a conventional central generator, so they are mainly based upon the non-fossil fossil fuel based resources. So they are called as mainly the coal and natural gas, and they are having the low efficiency. Okay, when you talk about the solar, that is having a higher efficiency. So we are moving based upon that. Second is the conventional generation is responsible for large share of human caused CO2 production. That is true because they are the thermal power plant which generates the CO2 in the larger amounts. Okay, so good smart grid attribute include the absolute reliability of the supply. Minimum, that is also true. We don't want to pollute the environment, and also we wanted the reliable operation of the power plants. Okay, so fourth, that is false because we need the in the smart grid we need the prosumers also. We can generate and we can supply also. They are basically, suppose you have a solar generation at your house. Okay, you can also sell to the grid. Okay, so that is false. Okay, option B is correct. Let's move further. Try to solve this. Okay, okay, I got option B as a two answers. Okay, let's wait for 10 more seconds, 10 15 more seconds. Okay, that is correct. Means ki option B is correct. Okay. So benefits of DERs basically to include the includes the distribution automation is basically to reduce the losses and increase the service reliability. That is first statement. Increasing focus on the RE is one of the drivers of the distribution automation. That is also correct because we have the DERs at the remote locations as well. Okay, so we need a certain automation to control that plant. Okay, load shedding, voltage regulation, capacitor control also, so that is also correct. So when you talk about the no role in the automatic customer meter reading, this is false because we need the aggregated demand. Okay, we wanted to see the user behavior. Okay, in that scenario we need the distributed automation at the different and meter reading data. Okay, so that is false. Let's move further, try to solve this. Okay, I got answer option C. Okay. Okay, let me give the solution. So When you see the first statement, this statement is related to FDR, which is called as fault detection, isolation, service restoration. Okay, so that is called as a detection, fault detection, isolation, and restoration device. Okay, so its proposed purpose is to detect the fault in a feeder section, isolate the faulted section quickly, and restore the service. Okay, so the option first is correct. Okay, second is talking about, second when you see, it is talking about topology processor. Okay, so topology processor is described as a background offline processor. Okay, you need the no internet connection which is happening in the background. If you don't have any internet connection, so it will run and perform the function which is already coded inside. Okay, so it is used to determine the topology of the distribution network, which is important from proper monitoring, analysis, and operation of the system. Okay. C is talking about the optimal network configuration you use to increase in energy losses versus voltage profile. That is false. Okay, that is to reduce the power losses, and conventionally you can see the energy losses. Also improve the voltage profile. That is false. Okay, and also when you see about the IVCC, IVCC is basically the integrated voltage VAR control. It means that whatever the voltage when it is dipping, you supply the reactive power support, okay, to improve the voltage profile. And when it is increasing, you just absorb the reactive power to reduce the voltage to an optimal level. Okay, so that is called as IVCC. To this is to reduce the network losses and maintain a desirable voltage profile. Okay, it helps in reducing the peak load by coordinating devices such as the capacitor bank or voltage regulator. You can say the shunt reactors. Okay, let's move further. Try to solve this. This is related to the SCADA devices. Okay, I got answer at option B. Okay, option B. Option B. Okay, that is correct. Option B is correct. Okay, so it is used to control one or more remote station devices to the from a master control station. That will be called as a slave control units, from where the master give the command and slave follows that. Okay. SCADA is also includes the digital control equipment, sensing telemetry equipment, and two-way communication from the plant in to the central means case center place center control station, and that when the center control station giving the command to the, that will follow that. Okay, it performed data acquisition from the metering equipment. So meters also already have the data acquisition facility by RS-285, or you have a LAN-based communication to the local server. So that is also possible. It don't include the alarm sensing. That is false. When the fault happen, it will give the command to the certain relay. So it have the alarm sensing facility. Okay. So statement 4 is false. So first, second, third statement is correct. Okay. Let's move further. Try to solve this. Okay, option B, I got one answer. Okay, option B, okay, okay. Let's wait for 5 more seconds, 5-10 more seconds. Okay, let me give the solution. So when you see the first one, two, three correct statements, option B is correct. Okay. So, but when you see wanted to see why it is correct. So, first statement telling about the a substation controller is basically a computer system designed for the substation environment. That is also correct. Control database store all the data in the single location. That is also true. ID tasks include the self checks, diagnostic, computer interface, communication interface, historical data storage, and integrated RTU input output. That is also correct. Integrating multiple functions into a single ID increases redundant equipment. That is false. When you all the function, more of the function is giving single ID, so it will reduce the redundancy. Okay, so that is also a benefit of the ID integration. So try to solve this. This is related to the AMI. Okay, I got multiple answer option B and option D also. Okay, let me give the solution. So this is basically okay. One second. So statement, all the statements are actually correct. So it's option D. Okay. So when the you talk about the first statement, AMI helps in utilizing load management, increase the revenue. Okay. So this is automatic metering infrastructure which helps utilizing the achieving the goals related to the load management and increasing the revenue. Utilizes the collected detailed information about the energy consumption and uses the information more effectively. Suppose you have a multiple houses, you just know the pattern of the all the aggregated houses and dispatch the power according to that. So based upon that, also you can increase the reliability and demand supply operation time you can increase. Okay. Second statement telling about the smart grid can use the MI backbone for distribution command. That is also correct because you need a distribution command and control strategy so that you can smartly operate that. Okay. One step toward the smart distribution network is adding the integrated applications such as EMS and optimization risk management. Okay, so suppose you have a battery storage, you have a solar PV, you have a house there. So you can operate and add energy management system such that the priority basis, like first you take the power from the solar PV, and when the solar PV is not there, then you can take the battery power. So in that scenario, you are independent. You can make your house independent of the grid. Okay. Lack of transmission capacity to meet increasing load is a channel. Okay, that is also correct. Transmission capacity means ki here when you talk about so as substantially so because lack of communication capacity is listed as one of the challenge because this issue affect the ability of system to handle the growing demand effectively. Okay, so whatever the cables, whatever the distribution feeder you have kept, okay, carrying capacity, as the load is getting increased, so that is creating a problem. You have to replace all the systems. Okay, so that is all a current technical problem is there. Suppose let me take an example. Okay, Suppose there is a house, okay, and it's a 6 kilowatt capacity, and then you ask that, okay, I will buy a EV, okay. EV with also having a suppose the charger is 6 kilowatt, okay. Now initially the 6 kilowatt power is there, now it got increased to 6, 2 plus 6, that is 12 kilowatt hour, okay. Now the current capacity of the feeder was related to 6 kilowatt, okay, so to cable. Now it will have to be increased to accommodate the remaining amount of the 6 kilowatt, okay. Now you have to change the cables for that. Getting my point? So that kind of communication is very required, because there is a diverse kind of load which is going to penetrate. Now currently when you see the data centers coming into the picture, now the data center also required a lot of power, okay, for the computation purpose. So these are the different kinds of load which is coming into the grid, so that is creating a problem, okay. So that's all for the today's session. If you have any doubt, so you can just ask me. Otherwise, we will end the session here. Okay, then. Thank you for joining. So let's end the session. We will meet in the next tutorial session. That will be mostly the last tutorial session of the this lecture. Okay. We will see the some. We will revise the problems also, and we will see some of the new problem as well in the last tutorial session. Okay. Thank you so much for joining. Okay.